And I would like to hand over to Mr. Lenkering for the next presentation for IO-Link. I hope it will be interesting for all of us in the next way, what we can do with IO-Link.
I hope
and
so
I'm
too.
glad that you're here. And yeah, please start your presentation.
Okay, thank you. Can I have the presenter?
Sorry.
No problem. So, good morning. I'm very happy to be here today. And I would like to show you a short presentation of our use case about how we use IO-Link in our company at LMZ Lenkering. My name is Dennis Lenkering. I studied mechanical engineering with a focus on development and construction. Since the foundation of LMZ in 2014, I'm the managing director of the company. And since then, I worked on many automation-related topics, such as Industry 4.0, interlinked production lines, modular production, robotics, and so on. I would like to give you a quick overview of our product portfolio. Our aim is, or our focus is, to help our customers to create the factory of the future. And first of all, we have our fully automatic systems. All processes work automatically without the permanent interaction of operators. And the material is fed and brought into the correct position automatically to be processed. We also have the semi-automatic systems. The process itself works automatically, but the operator handles the products in front of our system and packs them. Another product is our own modular system. We call it MP Ecoline. It is a modular base unit. The base unit has a PLC, safety, pneumatic, and the touch panel. And on this base unit, different articles can be produced. And in the area of the base unit, via interchangeable sets, they only have to be connected with Harting connectors to our system. We had the fully and we had the semi-automatic systems, and these systems can be combined into interlinked production lines. There are several systems connected to each other. We use it when we have many parts or many process steps to do. Of course, the handling and feeding systems must not be missing. These systems are, for example, needed for injection molding processes to insert some products to the molds. And often our systems are located directly at other production machines. And last but not least, the robot applications. We offer a wide range of robotics, from the world's smallest robots, the macadamic, and mobile robots as well. Here you can see one of our fully automatic systems. With our fully automatic systems, we are able to assemble, testing, and packaging processes. These systems can be used both standalone or inline to other production machines. For the handling, we use rotary or linear units, and robots are also often integrated. In this application, we assemble 6 magnets into a rotor, and at the same time, 2 parts are being processed. So this is one of our semi-automatic system. As you can see here, is a system is a gluing application, and also the system we will talk about today. This gluing application is with a robot. An employee places the required parts into the fixture in the front area of the system, and with our modular concept, we are able to produce different products on this machine, and different process steps can also be integrated. Yeah, more and more applications are being realized with robots, and robots almost stand alone. not always in our automation systems, but the robots can often stand directly to other production machines so that they can take over different operations. For example, we have the horse, we have a cobot, and many other robot applications. Here you can see the Macadamic, it's the world's smallest robot, for example, with the any feeder application. Okay. Here you can see a project overview of our project management. We have all processes in-house, so we can act fast and flexible. Okay, today I'm going to show you one of our applications. Let's have a look on our use case. Here we have a gluing application. We handle 3 different articles on this automation. I'll describe each station shortly. First of all, we have the station here in the front area with our IO-Link sensors. After that, we placed in gluing and the robot. After that, we have the pressing of the components and the separating of the not okay parts. And that's it, no big deal, just a gluing application. We placed one IO-Link master and an extension units and 17 IO-Link sensors underneath the rotary table. The sensors check the exact position of the distinguished products. We placed an industrial robot, a KUKA in this case, with a changing system so that the operator can change the gripper of the robot by himself. Okay. The gluing unit is installed in a fixed position in our machine cabin, and the robot moves the part along the gluing path of the product, and thereafter the robot assembles the 2 parts together. Thereafter we have the pressing of the component right over here, and we use pneumatic cylinders to press the components together so that the hot melt can harden. This is followed by the station for separating the not okay part in a separate container. By separating the insertion area in front of the system with the help of a safety light grid and mechanical shielding, we are able to have to have the automatic process in the background during the operator has the time to insert the articles in front of the system, and this is very positive for our cycle time. Our machines are basically based on aluminum profile construction, so we can be flexible and modular. So, why do we use IO-Link, and what are our benefits in this use case? First of all, we had 3 articles that are being processed, and these articles consist of several separate parts. And because of not using a separate sensor for each part, we place IO-Link sensors so they can be used for different articles. As a result, we are able to reduce the number of sensors. Another point is adjustability, due to the fact that we have several parts and several sensors. The components, the limits or the limit values must be set for each article. By using the values, we can not only see or set the limits, we can also visualize them graphically on the panel, the actual value as well as the range in which the value must lie. When a component changes, the operator can insert it into the fixture, see the actual value on the panel, and can set the new limits for the sensor directly on his own graphically on the panel. And this is a good point we have received from our customers, the easiness of setting the limits. An important point, of course, from our customer was the reduction of cost in case of replacing the sensors. So what was good and what was bad? In fact, we did not find any bad points. I asked our programmers and installers about it. What we think is good is that we can use the sensors from different manufacturers, so we can combine the sensors we need for every project. And it has already also been easy to integrate the sensors into the PLC. A great point is, of course, the adjustability of the sensors via remote maintenance. An event of a mall function, for example, our programmer do not have to explain the employees on site how they have to teach the sensor. They can directly teach the sensor by themselves. And of course, the positive feedback from the customers because of the graphic representation. And we were asked what topics we would like to see in the future. We see the advantages of this technology, and these advantages must also be visible to our customer, because of only as our customers want to pay for this technology, we are able to integrate this technology in our systems. Maybe we can integrate pilot projects for our customers with a discount maybe and win them over. Okay, that's it. I finished my presentation. I hope my information was helpful and interesting. Thank you for your attention.
Mr. Lenkering,
No
it
problem.
was a very interesting
I hope so.
presentation, and I've got some information from you that our system is right, but
Yeah.
we have to look for the future, how we stay on this way.
I think it's a marketing topic.
Yeah, it's a marketing topic. We have to do some work there. And thank you very much.